Okay, let's begin like this. Let's assume the flow of current. So let the current in this branch, let it be I1. Let the current in main branch be I. Then current here will be I minus I1. KCL. So then give polarity plus minus, plus minus, plus minus. And the charge across capacitor, let it be Q minus Q. So who is responsible for the charge across the capacitor? The I1, not I. I1 is what? dq by dt. This is what responsible. So now let's write the loop equation. Plus C minus IR minus I1 to R minus Q by C 0. Look at now what we have. I and I1 both are variable. Don't think that I will be constant, I1 is variable. I and I1 both are variable. And Q is also variable. And I1 I can write dq by dt. What to do with I? I should be replaced here in terms of I1. So I'll take help of other loop equation. Plus C minus I into, this is 3R, no? I into 3R minus I minus I1 into R equal to 0. 4IR plus I1R equals 0. So I is equal to E plus I1R by 4R. So this I'll substitute in the equation 1. This is the equation 1. Equation 2. Put 2 in 1. This will be E plus I1R by 4R. This is 3R minus I1 to R minus Q by C equals 0. So we have only I1 and Q. So now we can integrate. So this will become 3E by 4. 3I1 by 4 minus 3I1 by 4 and minus 2 this one. So this will be minus 11I1 by 4R minus Q by C equal to 0. I'll continue further here. I'll shift this one only. Now solving this, so 3E by 4 minus 11 by 4R, this will be dq by dt. Again the equation will come to the same form, you see, equal to 0. So this will be 3E by 4 minus Q by C, 11R by 4.
Sir, it's E by 4, not 3E by 4.
Yes, sir.
E by 4 only will come. Now, okay, 3 is there, no? Yeah. Okay, got it. So this will be, so C only you send it. So EC by 4 minus Q is equal to 11 RC by 4 dq by dt. Make coefficient of Q 1. So to generate the time constant, why I'm arranging things like this? To generate the time constant here. So this again, after rearranging this, dq okay, this 11 RC by 4 will be the time constant of circuit during charging. So integrating this 0 to Q T by lambda, where lambda is time constant. little bit different it came. It was RC, no? Now 11 RC by 4 it will be. Substituting, integrating this, we'll get minus of EC by 4, 0 to Q, T by lambda. So this will be EC by 4, 1 minus e to power of T lambda. Differentiating this, I'll get the current. So EC by 4 lambda e to power of T lambda. What is lambda? 11 RC by 4. So this will become E by 11R. So I got expression for current I1. No? Oh, symbol I1 it is. Huh? Yeah. This is what current through capacitor. So now once you know I1, substitute that I1 in the equation 2, you'll get expression for I. So like this, we are able to predict now current in all the branches. Means now this overall. So more than one loop comes, there's a method what you can apply it. If more than one loop comes, there's a method what you can apply it. Current through the capacitor is variable. What about current in the R? Because sir, there's no capacitor here. So current must be constant. No, here variable current. Here there'll be again a variable current. Current in all the branches will be varying with the time. If I ask you only time constant of circuit, or I'll ask you to directly write this equation without all this mathematics, no? So can we, is there any alternative method? This was the charge across capacitor at any time t. And there's an expression for current through the capacitor at any time t. What is Q equal to? Charge in capacitor at time t. Can we, and what is the steady state charge? EC by 4. And somehow if I can bring the steady state charge and lambda, and I know it's exponentially increasing, directly I can write equation. I can avoid all this mathematics. So what is a tricky method is, these are the circuit analysis here. The same circuit. So how to calculate without any mathematics, this I'll show it. So this was the circuit available given for us, R, 2R, R and 3R. No? Time constant of circuit is, don't write 2R by C, sir, they are in this one. No, time constant of circuit means the other resistance of other branch also will have influence. Not only 2R into C is what time constant. I'm making clear. Time constant of branch, they should not ask. I don't know, somebody asking in our exams. It's of no use. Huh? Nobody will say what is the time constant of this branch. But anyway, they ask in exam, I'm just reminding you. Time constant of circuit, time constant of branch. Only in our exams I've seen that word. No books, nowhere in the internet, nowhere in the world. Time constant of branch will never say. Time constant of circuit only. So time constant of circuit now depends on what? This R, 3R also, not only this 2R. That's what you see the equation. We didn't get lambda as R, 2RC. Here, look at this one. What we got? Lambda is 11RC by 4. Okay, well, so what is the time constant? It is this much, no? We have to interpret it like this. Huh? Time constant of circuit we have to interpret. take like that. So now one alternative method I'll show it, where all capacitor is there, no? Just write A and B, that one. There's a capacitor A and B. Find out the drop across capacitor. How to find out the drop across capacitor? So you know that where current will flow only in this branch, after a long time. So what you have to do, you have to draw is at steady state how the capacitor will behave like at t equal to infinity, or steady state. At steady state, where all capacitor there, we have to write open circuit. Don't write C infinity, just leave it this one. So this is R, this is 2R, this is R, this is E. Calculate the drop across AB. So where the current will flow only in this particular branch, 3R and R. Why no current will flow there? Because there's an open circuit, no current will flow. So I want VAB. So give polarity plus minus, plus minus. So what is the expression for I? I equal to E by 3R plus R, E by 4R. So write down the loop equation. VA minus 0 into 2R. If you have any resistor, write it. No problem. So this is again current I into R. Why negative sign? I'm tracing the loop like this. Plus VA 0 into 2R minus I into R minus VB equal to 0. So this VAB I got IR. So this should be equal to E by 4. So I got something like this, VA greater than VB. See this. So even which plate will be positive, negative, which plate of capacitor positive, negative open, this equation will tell us. VAB I got positive. So therefore VA greater than VB. So this end will be positive, A will be positive, B will be negative. Then what is the steady state charge equal to? Q infinity equal to C into VAB. C we know, VAB is how much? Is it the same equation what we ended up? Look at this. EC by 4. So what is this EC by 4? Should be steady state charge. In general, what is the equation for charge across capacitor? Q equal to steady state charge in the bracket 1 minus e to power of minus t lambda. So how to determine the steady state charge? There is one method. How to bring the time constant? For time constant, what you should do, where all cell is there, replace cell with internal resistance. What is internal resistance of cell? 0. So I'll make EMF 0. It'll become short circuit. I'm making things clear. Where all cell is there, replace with an internal cell, internal resistance. So since there's an ideal cell, so therefore I'm replacing with a short circuit. So this is 3R. Here you write it EMF 0. If any internal resistance, that you bring it here. Able to get that one? If any internal resistance of cell is there, that bring that R here. There's no internal resistance. It's ideal cell. Calculate the effective resistance. So what is RAB is equal to 2R plus 3R into R by 3R plus R. No? So these two are parallel. That effective is in series with this. 3R by 4. So this will be 11R by 4. The effective resistance as seen by the capacitor terminals. How much of resistance as seen by capacitor terminals? So then what is the time constant? This should be equal to RAB into C. Then what is the expression for? So this is a very easiest way of getting expression for charge, no? What you can do it. One alternative mathematics is there. All writing loop equation, KVL, solving, integrating. Directly what happened? What is the expression for charge across capacitor? Steady state charge. Oh. Wait, I'll share it. Oh, no. So what is the expression for steady state charge here? So this was the Q E C E by 4, this one. No? So directly you can write that equation. How to find out steady state charge? Find the drop across capacitor after long time. After long time, you have to replace capacitor with open circuit, then calculate the VAB. Then how to calculate the resistance? The net resistance as seen by capacitor.